Momentum quiz number 2. Kicking it up a notch. Number 3 was tough. Yeah, it was. So your test is next class. Number 1, I see a collision. Now, what I haven't talked about lately is impulse. What's another word for impulse? Change in momentum, and what's changed anything? So I think on your test, on the multiple choice, I am giving you one question where instead of it being a collision, I give you a before velocity and after velocity, and I say find the impulse. But they are at angles. You're going to have to subtract the vectors. Final velocity plus negative initial velocity. Okay? That's fair game. I mean, not really as a written, but certainly as a multiple choice. Anyways, I'm going to draw compass rose. I see a collision. The sum of all the momentum before equals the sum of all the momentum after. Before the collision, what's moving? Mass 1, mass 2, or both? The car. No, both. Momentum car initial, momentum truck. How about 2? Truck initial. And they stick together. I'm going to dulp. It says that the car due east. How big? Mass times velocity. 1,300 times 30. You know what? I can do that in my head. 39,000, right? Plus. The truck is moving 60 degrees north of east. North of what? North of east. North of what? North of east. Draw east first. What of east? North of east. How many degrees? 60 degrees. How big? Mass times velocity. 3,200 times 20. You know what? I can do that in my head as well. 64,000. Carl, this one's not too bad. They gave me both of the vectors that I know on the left side, so I can add them together. How would I add them together, Carl? Any suggestions? Draw them tip to tail? You don't say. So I'm going to do a nice big triangle over here. 39,000. 64,000. Should be almost but not quite twice as long as the 39,000. So they move off together. There is the momentum of both final. It's going to be north of east, for what it's worth. The angle they gave me is that one. Doesn't help me. Or does it? Pardon me? I can't go Zorro because this Z here is not parallel. The top and bottom have to be parallel. Good thought. 180. The other trick we've been using is straight lines are 180 degrees. So if the right chunk is 60, the left chunk has to be how big, Darian? 120. And now it's going to be cosine law. It's going to be cosine law. In fact, you know what? I'm just going to show you the rest of it so you can mark it yourself. Did I give you quiz version 2 or version 1? I think it was version 2, right? So when I crunch the rest of it, I got momentum final equals 90,072 when I use the cosine law. There it is. Now that's the momentum. How do I find the speed? Divide by the mass. Since they're stuck together, it's going to be divide by both masses. Divide by both masses. So I got a speed of 20.0. And then I said, okay, theta, I can use the sine law. Sine of theta over 64,000 equals sine of 120 over 90,072. And I got 38 degrees north of east. This will be a 7-mark question on your test as opposed to 4. If I was giving you marks, I would give you 1 mark if I saw that you'd recognize that it was conservation of momentum. Then I'd give more part marks out if this was a 7-marker, but for now I said, I'll give 1 if they write down the momentum correctly, 1 if they find the speed, and then 1 mark for the theta and the what of what. Is that okay? Okay. Number 2. A pendulum is hanging from a frictionless, massless string that is 15 meters long, similar to the ballistic pendulum picture that we did in Lesson 7. Pendulum weighs 2.4. A bullet leaves a gun traveling at 380 meters per second. It hits the pendulum and sticks. What height? You know what? This has 2 parts. There's going to be the collision and the swing. There's going to be the collision and the swing. The swing is a change in height, change in speed, curvy path, conservation of energy. In fact, for the swing, we can say nothing, nothing. We can say a half mv initial squared equals mgh final. Which mass? The mass of both. Doesn't matter, masses cancel. We can say the final height is going to be the initial speed after the collision squared divided by 2g. In fact, we can also say, I don't need that much room, but I might need more room for the momentum. Momentum of the bullet initial equals momentum of both final. It's a nice linear collision. So when I crunch the numbers, do you end up with 0.284? I gave 1 mark for saying this was momentum. I gave 1 mark for getting 2.36 meters per second after the collision. Gonna make it, Anthony? You're looking a little tired. Okay. You gave 1 mark for recognizing this is conservation of momentum. Conservation of energy. And 1 mark for the 0.284. Now, the trickier part was the bonus. Oh, by the way, this quiz is actually going to end up being out of 16, not out of 12, because apparently Mr. Dueck can't add. So for the bonus, now I had to work backwards. Now, if it swings up, okay, you know what? I can work my way backwards to figure out, if you tell me the height, I can work my way backwards to figure out what VI must have been. Oh, no, I just wanted how many joules of heat. You know what? I said, okay, now the collision is this, except there's heat. I can still say PEI is 0. I can still say that kinetic final is 0 at the top of the swing. I said heat's going to be the initial kinetic energy minus the final potential energy, which is going to be a half mv squared minus mgh. Here masses don't cancel because there's no mass in heat. The initial kinetic energy was a half times m times 2.36 squared minus, this time they told me it only went that high. How much energy did I lose to heat? 3.18 joules. 1 bonus mark for that. Is that okay, Sarah? Thumbs up. Yep, yep. Let's talk about number 3. This one I'll do. Number 3, a 100 kilogram shell explodes, boom, into 3 fragments. Fragment A flies off, yuck. Fragment B flies off north. Find the velocity of fragment C. You'll have to use the sine law on the coast. Okay. I've turned the page just so I feel better. I'm going to draw that. This is a job for conservation of momentum. What's the momentum before the explosion? Nothing. 0. What's the momentum after the explosion? Well, it's going to be 0, but it's going to be piece 1, piece 2, and piece 3, or fragment 1, fragment 2, and fragment 3. It says fragment, oh, you know what? Not 1, 2, and 3, A, B, and C. Let's be consistent, Mr. Dueck. Why don't you make your life easier and go A, B, and C? Sheesh. Fragment A flies off 30 degrees north of east. North of what? North of east. North of what? North of east. I'm going to draw east first. I'm going to go north of east. 30 degrees. How big? Mass, 40, times velocity, 32. 1280. Plus due north. 25 times 48. Should be 1200? Yeah. I've had about 5 kids come and see me for help on this, and they've all had a wonderful vector triangle. They've all said, oh, I got this. I got this, almost exactly the same length, but not quite. And they've all wonderfully drawn the resultant back to where I came from, because that's the definition of 0. And they've said, there it is. And then they've gone, well, they said that's 30 degrees, and they've said, You got 2 strategies here. The first strategy says, what's 5 plus 6? Seriously, what's 5 plus 6?
11.
What's 6 plus 5? Adding the order doesn't matter. If you have a really yucky triangle, try drawing the second vector first. In other words, the same triangle would be this one. Where this angle right here is 30 degrees. How big is that angle right there? How big is that angle? 120. So that's one way. Or the other way, here's your cue, Jordan. There is a Z if you add a horizontal line right there. This little angle right here is how big? And how big is this angle right here? $90. How big is the whole angle if it's 90 and 30? 100 and 120. Okay? That was tricky part number 1. How many of you drew the first triangle? I think most of you. Okay? So I'm going to solve the first triangle, but I'm going to get rid of a few of these lines. So it's going to be cosine law. It's going to be momentum c squared equals 1200 squared plus 1280 squared minus 2 1200 1280 cos 120. It ends up being 2148. Divide by the mass of C. They didn't tell me the mass of C. Yeah, but they told you the whole shell was 100 kilograms, and they told you the first fragment was 40, and the second fragment was 25. I'm pretty sure that means I have 65 kilograms used up, 35 kilograms left. So I think if you divide by 35, whoop, you get 61.4 meters per second. Okay. Then the second yucky part was the angle. Oh, wait a minute. No, this isn't too bad. That's where I'm coming from right there. That works okay. I ended up with 60 degrees south of west. And you can see I drew the 1200 first and then drew the 1280 in mine. So if you did that, you got, I think, 60 degrees south of west. Otherwise, I think you would get, is it 30 degrees west of south? Or am I wrong on the angle? I have silence here. What's going on? Okay, let's solve this one. So what did I say this was? 2148? So you'll have sine theta over 1280 equals sine 120 over 2148. 1280 sine 120 divided by 2148. 31, is it 31 degrees?
I got 30, but I did the other triangle.
Did the other triangle. Okay, you know what? Maybe the 2148 is rounded off. 1200 squared plus 1280 squared minus 2 times 1200 times 1280 cos 120 square root. Oh, it's 2148, blah, 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 blah. So it's going to be 1280 sine 120 divided by answer button. I want to make it a 1280. Shift sign of that. Yeah, I'm getting 31 degrees west of south. Is that right? Okay. Or 60, you know what? It should be 59 degrees south of west. I'll have to fix that. 59 degrees south of west. Now, the only tricky part, Darian, is doing the second triangle is tricky. I found that, and then I kind of drew a line here and added an extra 30 degrees, and that's how I was able to get my full angle. Is that okay? Last one. Curling rock. Okay. We have a collision. Conservation of momentum. The initial rock is traveling due east. I'm going to skip a step or two. So it's going to be 3.2 times, I don't know the initial momentum. It's that. After the collision, the first rock moves off north of east, 38 degrees, and it has a mass of 3.2 and a velocity of 8.2, or a speed of 8.2. So it's going to be 3.2 times 8.2, 3.2 times 8.2, 26.24, plus the second rock moves off 5.4 meters per second at a direction of 48, south of east, and it has a momentum of 4.1 times 5.4. How am I going to add these together? I'm going to draw them tip to tail. Now this ended up being kind of nice. I said, okay, I got the 26.24. I got the 22.14, and I said, I know they add to due east, so here's the momentum of object 1 initial. That angle is 38 degrees, and so I said, cosine law. And I said, well, wait a minute. They told me that this angle was 48, which means this angle is 48 because of Zorro. And I said, holy smokes, I've got pairs. I can use the sine law. You don't have to, but I can. In fact, what does every triangle have to add to? So I said 180 minus 38 minus 48. I said, this angle here is 94 degrees. It's going to be sine of 94 over mystery momentum equals, and you could either go sine of 38 over 22.14, or you could go sine of 48 over 26.24, and it was, I can move stuff diagonally across. Well, here, let me show you. So I ended up with a momentum of 35.87, which you would also get with the cosine law. I divided by the mass of object 1. I got a speed of 11.2 meters per second. And that's all this question wanted because they gave me the initial direction, east. So all this question wanted was the speed. Okay. What could I add to this to make this a little bit trickier? Oh, I could have, instead of saying find the initial speed, I could have said how much kinetic energy was lost. Well, you'd have to find the initial kinetic energy, which is a half mv. I don't know v. Half mv squared. And the final kinetic would be a half m mass 1 v1 squared plus a half mass 2 v2 squared. And if you subtracted, you'd find that you'd lost some kinetic energy. What else could I ask? And that's probably about it. Can you give yourself a lovely score out of, count 'em, 16, please?